Welcome. Today, we are looking at redox reactions at an advanced level. This is a key topic in your chemistry exams for SS2. Pay close attention. Let us begin. First, let me explain what redox reactions are. Redox is short for reduction oxidation. Redox reactions are chemical reactions in which electrons are transferred from one substance to another. Oxidation is the loss of electrons. Reduction is the gain of electrons. These two processes always occur together. When one substance loses electrons, another substance gains them. The substance that loses electrons is oxidized. It is called the reducing agent. The substance that gains electrons is reduced. It is called the oxidizing agent. For example, in the reaction between sodium and chlorine, sodium loses an electron to become Na+. Sodium is oxidized. It is the reducing agent. Chlorine gains an electron to become Cl. Chlorine is reduced. It is the oxidizing agent. Redox reactions are everywhere. They occur in batteries, respiration, photosynthesis, corrosion, and many other processes. Now, let me explain oxidation numbers. Oxidation numbers are a way of keeping track of electrons in a chemical reaction. They are also called oxidation states. An oxidation number is a positive or negative number assigned to an atom. It represents the number of electrons that an atom has gained, lost, or shared. The sum of oxidation numbers in a neutral compound is 0. The sum of oxidation numbers in a polyatomic ion is equal to the charge of the ion. Some rules for assigning oxidation numbers are important. The oxidation number of an element in its free state is 0. For example, Na, Cl2, O2, and Fe all have oxidation number 0. The oxidation number of a monatomic ion is equal to its charge. For example, Na+ has oxidation number +1. Cl has oxidation number -1. The oxidation number of hydrogen is usually +1, except when it is bonded to metals, then it is -1. The oxidation number of oxygen is usually -2, except in peroxides, where it is -1. The oxidation number of fluorine is always -1. The oxidation number of alkali metals is always +1. The oxidation number of alkaline earth metals is always +2. Oxidation numbers are useful for balancing redox equations. They help identify which species is oxidized and which is reduced. Now let me explain how to identify redox reactions. A reaction is a redox reaction if there is a change in oxidation numbers. The oxidation number of at least one element increases. The oxidation number of at least one element decreases. The element whose oxidation number increases is oxidized. The element whose oxidation number decreases is reduced. For example, in the reaction 2Mg plus O2 equals 2 MgO, magnesium goes from 0 to +2. Its oxidation number increases. It is oxidized. Oxygen goes from 0 to -2. Its oxidation number decreases. It is reduced. This is a redox reaction. In the reaction HCl plus NaOH equals NaCl plus H2O, there is no change in oxidation numbers. The oxidation numbers of all elements remain the same. This is not a redox reaction. It is a neutralization reaction. You must check oxidation numbers to determine if a reaction is redox. Now let me explain oxidizing and reducing agents. An oxidizing agent is a substance that causes another substance to be oxidized. It is itself reduced. It gains electrons. A reducing agent is a substance that causes another substance to be reduced. It is itself oxidized. It loses electrons. For example, in the reaction 2Mg plus O2 equals 2 MgO, oxygen is the oxidizing agent. It causes magnesium to be oxidized. Oxygen is reduced. Magnesium is the reducing agent. It causes oxygen to be reduced. Magnesium is oxidized. The oxidizing agent is the substance that contains the element that is reduced. The reducing agent is the substance that contains the element that is oxidized. Strong oxidizing agents have a high tendency to gain electrons. Examples include oxygen, chlorine, fluorine, and potassium permanganate. Strong reducing agents have a high tendency to lose electrons. Examples include alkali metals, hydrogen, and carbon. Now let me explain how to balance redox equations. Balancing redox equations can be done by the oxidation number method or the half reaction method. The half reaction method is commonly used for reactions in aqueous solution. First, write the two half reactions, one for oxidation and one for reduction. Balance each half reaction for mass and charge. Multiply the half reactions by appropriate factors so that the electrons cancel. Add the half reactions together. Simplify if necessary. For example, consider the reaction between potassium permanganate and iron 2 sulfate in acidic solution. The oxidation half reaction is Fe2 plus equals Fe3 plus E. The reduction half reaction is MnO4 plus 8H plus 5E equals Mn2 plus 4H2O. Multiply the oxidation half reaction by 5. Add them together. The electrons cancel. The balanced equation is MnO4 plus 8H plus 5 Fe2 plus equals Mn2 plus 4H2O plus 5 Fe3 plus. This method works for all redox reactions. Now, let me explain the importance of redox reactions. Redox reactions are essential for life. Respiration is a redox reaction. Glucose is oxidized to carbon dioxide and water. Oxygen is reduced to water. Photosynthesis is a redox reaction. Carbon dioxide is reduced to glucose. Water is oxidized to oxygen. Batteries work by redox reactions. In a battery, a metal is oxidized at the anode. Another substance is reduced at the cathode. The electrons flow through the external circuit. This produces electricity. Corrosion is a redox reaction. Iron is oxidized to iron oxide. Oxygen is reduced. Rusting damages iron and steel. Redox reactions are used in industry. They are used to extract metals from their ores. They are used to manufacture chemicals. They are used in electroplating. Understanding redox reactions is essential for understanding chemistry. Now, let me explain the electrochemical series. The electrochemical series is a list of elements arranged in order of their standard electrode potentials. It shows the relative tendency of elements to gain or lose electrons. Elements at the top of the series are good reducing agents. They lose electrons easily. Elements at the bottom of the series are good oxidizing agents. They gain electrons easily. The electrochemical series can be used to predict the direction of redox reactions. A more reactive metal will displace a less reactive metal from its salt solution. For example, zinc is more reactive than copper. Zinc will displace copper from copper sulfate solution. The zinc is oxidized. The copper is reduced. The electrochemical series is useful for understanding corrosion, electrochemistry, and metal extraction. Now, let me explain the application of redox reactions in daily life. Bleaching is a redox reaction. Bleach is an oxidizing agent. It oxidizes colored substances to colorless substances. Hydrogen peroxide is used as a bleach. It is also used as a disinfectant. It oxidizes bacteria and viruses. The bleaching of hair involves oxidation. The melanin in hair is oxidized to a colorless compound. The rusting of iron is a redox reaction. Iron is oxidized to iron oxide. Rusting can be prevented by painting, galvanizing, and alloying. The burning of fuels is a redox reaction. Fuels are oxidized to carbon dioxide and water. Energy is released. This energy is used to power cars, homes, and industries. Redox reactions are everywhere. A common exam question asks you to define oxidation and reduction in terms of electrons. Here is a sample answer. Oxidation is the loss of electrons. Reduction is the gain of electrons. Oxidation and reduction always occur together. The substance that loses electrons is oxidized. It is the reducing agent. The substance that gains electrons is reduced. It is the oxidizing agent. The loss of electrons is oxidation. The gain of electrons is reduction. Another exam question asks you to assign oxidation numbers to elements in a compound. Here is your answer. The oxidation number of an element in its free state is 0. The oxidation number of a monatomic ion is its charge. The oxidation number of hydrogen is +1, except in metal hydrides, where it is -1. The oxidation number of oxygen is -2, except in peroxides, where it is -1. The sum of oxidation numbers in a neutral compound is 0. The sum of oxidation numbers in a polyatomic ion is its charge. Another exam question asks you to identify the oxidizing and reducing agents in a reaction. Here is your answer. The oxidizing agent is the substance that causes another substance to be oxidized. It is reduced. The reducing agent is the substance that causes another substance to be reduced. It is oxidized. To identify them, look at the changes in oxidation numbers. The element whose oxidation number decreases is in the oxidizing agent. The element whose oxidation number increases is in the reducing agent. Let me give you a quick summary. Redox reactions involve the transfer of electrons. Oxidation is loss of electrons. Reduction is gain of electrons. Oxidation numbers keep track of electrons. An increase in oxidation number is oxidation. A decrease is reduction. The oxidizing agent is reduced. The reducing agent is oxidized. Redox reactions are essential for life and industry. The electrochemical series lists elements by reactivity. Balancing redox equations uses the half-reaction method. Practice these concepts. When you have them down, move to topic 2.